All right. So hello everyone. My name is Charles Mitchell. I'm with Commscope, and I want to talk to everybody today about how IONE is going to simplify DAS for enterprise. So anybody in the area that wants to come and join, and whoever is online watching remotely that couldn't make it here, please come sit and learn about IONE. So in today's marketplace, we're seeing more and more people that are using smartphones, tablets in the enterprise environment. So more employees using more devices. IP traffic is also something that's changing dramatically. Traditionally, we've had a lot of usage over the hardwire, your LAN network, but more and more is going to be transmitted over the Wi-Fi. And so the Wi-Fi needs are going to increase, cellular needs are going to increase, and actually most of the cell phone calls that are made today are 80% of them are actually indoor, but the carrier network is more of a macro-oriented outdoor environment. As well as the Wi-Fi is also changing. Next-gen Wi-Fi is going to be up to 10 gigabits, so we really need a solution that's going to be able to handle all of these different things as they change and be scalable and flexible with the market. Planning for wireless in the indoor space is very, very challenging. You have, again, more devices, more smartphones, new smartphones, tablets, everything becoming new and interesting every day. More bandwidth. Today, people are uploading, downloading large files, streaming video, streaming audio. Right now, if you're watching me online, you're streaming video and audio. There's also a lot of different standards that you have to take into account, IEEE, Wi-Fi, etc. Traditionally, 80% of recently installed corporate wireless networks are going to be obsolete because of poor infrastructure planning. So unless a lot of planning goes into it, everything will be obsolete very quickly. So convergence is also deepening. Everyone is starting, used to have separate devices for separate tasks. Yesterday we had your desktop computer with a LAN connection and power connection, hardwired. Your cell phone signal was really only transmitting and communicating with the outdoor macro network. Today we have added, in addition, your Wi-Fi, and also you've added some DAS. So now we have a combination of indoor wireless, but we're still relying heavily on the outdoor macro sites. Tomorrow what we want to be able to have is eliminate the outdoor macro sites from the situation and then have only your DAS infrastructure that's doing also combining with your Wi-Fi, so you have one platform for all your wireless technology in your enterprise space. In the future, we want to move everything to a wireless platform. We don't want outdoor macro, we don't want hardwire. Whenever it's possible, we want to be doing everything with wireless. So, as it is today, we have in the market predominantly operator-owned, but as in the private space, we have been seeing, and we don't know exactly when, but enterprise market is going to take over the private buildings. And they want to be able to own something that is flexible and scalable and something that can handle any type of change in the market that is needed. And of course, the operators are going to be predominantly staying in the public spaces. So what would be the ideal DAS for enterprise? It has a couple different things that we need. It would be simple, first of all, and mirror IT data network infrastructure. So just like your IT infrastructure today is already maintained by your IT department, something that mirrors that would be easy and simple to use. Easy to install and commission. Provide ultimately flexible and traffic steering and flexibility. So not only be able to handle changes and expansion in your system, but also be able to, on the fly, change the needs in your building from an hour-to-hour basis even. And also be completely PIM-free. So for this we have IONE. And to do all of those things, we start off with a system that is frequency agnostic, and from anywhere from 380 megahertz to 2700 megahertz, anything in that band, IONE can transmit and provide to the user. Any frequency, technology, multi-operator worldwide. UMTS, CDMA, LTE. And as it changes with the times, there's new technologies. The most that we're going to have to do is do a software update on the IONE. It's still frequency agnostic, it can still transmit any of those technologies. And Last but not least is traditional IT infrastructure cabling. So it's using multi-mode fiber and single mode fiber that may already be in your building and uses Cat6a Ethernet cabling. So we want to have simplicity in every phase of installation, use, commissioning. And the design is going to be simplified because you don't need different types of hardware for different frequencies. You don't have to worry about what band you're going to actually install. You can install it, and then when the carriers come in, you can hook them up, and whatever band they choose to use, it's already ready for it. Anywhere from 380 to 2700 megahertz. Simplified RF planning. So right now we have a lot of tools like IBWave, and you have to basically do plots and determine what the RF pattern inside your building is going to be based on what you're going to install. What we want to do with the INE is actually mirror the Wi-Fi infrastructure. So just like you can transmit with the INE, additionally Wi-Fi as well as wireless signal, we want to basically make it easy to install and easy to plan. So in the enterprise space, you would basically be able to mimic the Wi-Fi installation process. And it uses the same structured cabling rules as Wi-Fi. So Cat6a, 100 meter cable lengths, just the same. The installation, Cat6a is essential. It needs the 10 gigabit data rate. If you use Cat6, which is only 1, then you're not really, it won't work as well, or you won't be able to use as much spectrum as what we want to be able to provide with this 320 megahertz. Multi-mode and single mode fiber could already be installed and ready to use, so you can use the patch panels that are already in the building to run from floor to floor. And there's also a huge installer base. So you don't need as much specialized installers being able to use RF cabling, coaxial, etc. There's a large number of people, and ideally your IT department that you already have can install and can install the system. Automatic signal commissioning, automatic signal detection, automatic hardware detection. So anything you connect to the system, it's automatically going to be recognized and without any problems. Commissioning can be done remotely. You don't have to have an RF engineer on site. If your IT department installs all of this equipment, they just need to connect it, remote access to onto your LAN network, and then someone can log in remotely and assign what sectors to what UAPs, universal access points, and exactly everything is set up that you can commission everything through the software. So, scalability and flexibility. You have a lot of options when it comes to traffic steering. So you input your RF signal into the RF donor card at the central access node, the head end, and from that point you can route any signal you input to any UAP, universal access point, independently of one another. So if you need more capacity in a specific area, say you have 10 UAPs with only one sector, now you can actually split that if you have an available sector and do 5 UAPs per. So on the fly you can actually reassign what data is being sent to what area. And you can carry all licensed spectrum on a single Cat6a cable. So the infrastructure, again, Cat6a is very important. It does provide PoE to the units, and you can actually daisy chain one off of the other. You can have up to 2 on the PoE on one Cat6a cable. So if you're doing MIMO, what you have is the ability to run a long Ethernet run. So let's say 80 meters to the location of the first UAP, and then 3 meters to provide separation for your LTE MIMO. And then you have power over Ethernet on both. And all the power can be provided from the head end. You don't need any infrastructure in the location. All you do is install the cable run and the UAP. So, next, multi-mode or single-mode fiber is supported, and from there you're going from your CAN, central access node, to your 10. You have also an auxiliary port. Instead of daisy chain a UAP, you could actually daisy chain a Wi-Fi access point or another IP device like an IP camera. Growing coverage. So you can start with 1 CAN and have only 16 UAPs, but anytime you need it, you can either add additional CANs in the head end, or you can add 10s, transport expansion nodes, and you can go up from 16 to 4,096 UAPs anytime that you need. If there's a new band, if new spectrum is allocated or sold or bought, it can be added to the system just by a simple software upgrade. And of course, like I said, you can daisy chain 2 UAPs, one after the other. So, universal hardware. And this is important because The same hardware that would be used here in the USA is going to be used worldwide, and there's only going to be 13 active SKUs that you have to manage for your stock. There's of course additional components with blind plates, etc., but for active components that can fail, you only have 13 that you need to carry as backups and spares. Here on the left-hand side, we have the CAN, Central Access Node, and at the top we have the EPOI. So for higher power base stations, this is going to be an attenuator. The RFD card on the right-hand side of the unit can handle up to 27 dBm in power. So we have the attenuator if need be, and then the input, the RF donor card. On the left-hand side, we then have on the bottom portion the Cat6a Ethernet connections for the UAPs, as well as fiber connections for the transport extension nodes, which is on your bottom right-hand side. And from the transport extension node, you connect additional UAPs. The UAP, Universal Access Point, is at the top right and is installed in the drop-down ceilings of most enterprise buildings. So, flexible and expandable. There's two key points to this slide, and one is the different types of cabling that's used and where, as well as the way that you can structure your building. So the first thing I'd like to point out is you don't need a tent on every floor. If the cable run is short enough, you can go from floor to floor, but again, you're limited by the 100 meters of the Cat6a cable run. The other thing is the RF cabling is located only in the head end. So on your black cables on the top right, we have that's only in the head end. Everything else is either all standard IT infrastructure. So we have in the red fiber connections, either multi-mode or single mode, and then in the blue to the UAPs is your Cat6a cabling, or Ethernet cabling. Automatic hardware detection. So whenever you install this system for the first time and you're logged into the web GUI, as you install your RF cards or all your cards at the head end, there's going to be automatically detected here in the web GUI. So what ends up happening is not only are they detected automatically, but they're also upgraded the software automatically. So if a card goes bad, you swap it out, it's going to automatically update the software and you plug everything back in and keep going. It's hot swappable, it's very easy for anyone to maintain. The UAPs also are going to be automatically integrated into the system whenever you connect them with the Cat6a Ethernet cabling. As long as you do have the PoE turned on that port, the unit's going to power up, be detected, and upgrade. So this is probably the best feature of the INE and the most powerful, and this is going to be the automatic signal detection. So automatic signal detection allows you to get every piece of information about the RF signals that you've inputted that you need to commission the system. So you plug your base station into the RFD card, your RF donor card, and you're going to get the carrier, the center frequency, the band, the bandwidth of the signal, as well as the center frequency, cell ID. It provides you all of the information it's going to decode. So, and the other great feature is in the web GUIs, everything is searchable. So whenever you're creating your signal sets to provide, say, hey, I want this number of this sector on this UAP, you actually can search by the cell ID. So if you know that this one particular zone needs this cell ID, you can search for that, drag, drop, and then you're done. So, signal flexibility. Like I said before, any signal can be routed to any UAP. So we have this example, we have inputted at the CAN, we have 3 different signals, separated by white space, unused spectrum. Now you'll notice that when transmitting these 3 signals, or in the case of the bottom 10, only 2 of the 3, you'll notice that there's no gap anymore. And this is because you're not transmitting any unused spectrum. You're only transmitting used spectrum whenever you're talking about the UAPs. So on the first 10, we have 3 signals going. On one UAP, you're transmitting all 3 signals, but on the second, you're only transmitting 1. On the second 10, you have 2 signals being transmitted and transmitting both on both UAPs. So everything is completely flexible and completely customizable. So, last thing that we have here is that everything is simplified. So, automatic hardware detection, automatic signal detection, intelligent alarming, and complete system visibility. So, everything can be done through the GUI and the software. So, in conclusion, we have a case study. And what the case study really is about is about trying to show INE in action. And what this is we took carrier aggregation as well as MIMO and combined them. And so we took two 15 megahertz LTE channels, combined them, and also using MIMO 2x2, the theoretical maximum data rate is going to be 225 megabytes per second. Now, what we actually measured was 215. And so we're at 96% efficiency. And what this really shows is that the transmission across the INE DAS system has a negligible effect on the theoretical maximum speed of your RF wireless signal. So that's very important to me, is knowing that even with this DAS setup, that you're not going to have any effect on the performance of your system. So everything can run on your Commscope network INE. All right. So, does anybody have any quick questions? Okay, so the question was handoffs between outdoor macro and indoor. So, one of the possible features of the INE is it actually can, instead of being a transmitter, you can actually use it to detect signals. So if you're having a problem with maybe some handoffs, you can actually go and find where the signal's coming in too strong from what side of the building, and then you can actually try to move some UAPs closer to the outside of the building to make sure that edge is covered better than what the macro signal coming in is. So, I mean, of course it's going to have some problems with this, but these are problems that are detectable and you can fix them. Okay. All right. Anybody else? All right. So, I think. I think it should already be available, yes. So, yeah. Yes. All right. Thank you, everybody. Thanks for attending, and whoever's online, thanks for attending as well.